In 1954, Pier Luigi Nervi and his son Antonio founded Studio Nervi, the architectural firm that would work alongside with Nervi and Bartoli, which was a construction company. In 1960, his other two sons, Mario, who's an engineer, and Vittorio, an architect, joined the firm as well. Some have said that by 1960, Nervi was the most famous structural engineer in the world. I would say he was at least one of the most famous structural engineers, and his structures of the 1960 Olympics in Rome earned him a Royal Gold Medal, which was the world's most prestigious architecture award at the time. It took him 4 years from conception to construction to complete the 4 structures for the Olympics. So Tulia, why don't you tell us, just list them at first. What were the 4 structures that he completed for the Olympics?
Oh, the 4 structures were Little Sport Palace, the Palazzetto dello Sport, the Flaminium Stadium, which is very near, the large Sports Palace, which is the Palazzo dello Sport in Italian, which is in the EUR district, and the Corso Francia Viaduct, which is the road which pass throughout the sport village.
So it's an elevated highway.
Yeah, an elevated highway in a certain sense. Okay. But these 4 buildings, these 4 works were built by the same company, the company by Nervi, which is a very little company. And he had only 4 years because the Olympic Games started in August 1970. So he had to work very fast, and this was possible only due to the Nervi system.
So the Corso Francia Viaduct is a prefabricated and pre-stressed V-beams, which have sculptured pillars. In this lecture, we're not going to cover this structure very much, just to mention it here, because it's not a vaulted structure, but it is certainly one of his greatest designs and done very economically, and as we're mentioning, very quickly. These 4 major works done in 4 years for a small company is quite impressive. What we want to talk about first is the Little Sports Palace, referred to as Palazzetto dello Sport. And this is the structure that we're standing in here today. And for this, I'm going to let my colleague describe to you how it was built, because it's really amazing.
Yeah. Nervi had only 14 months to build the buildings, and he wants to prove the potentiality of the Nervi system. So he divided the dome, which is 60 meters in diameter, in 1,620 pieces. These pieces were prepared on the ground and then assembled in the final work. He designed 13 prototypes, so 13 different types of rhomboidal tavelloni. He used only 13 types of tavelloni, which was repeated 108 times each. But how he can really prepare these pieces? Well, he started with the ordinary concrete site work. So he started to build the 36 trestles that are around the building.
You're talking about the inclined buttresses.
Yeah, the inclined buttresses.
The inclined buttresses,
yes.
Okay.
And these are made in an ordinary way with the false work in wood. Very simple, reuse many times. But really near this main work site, there is another work site. And there he prepared thousands of pieces. In which way you can prepare pieces and to be sure at the end that these pieces could be really assembled in a 3D dome. So what he did is to prepare a template of the dome, a sort of slice of the dome, 10 degrees in wooden. On this slice, the workers drawn the line, the central line of the ribs. So they reproduce the drawings of the diagonal ribs. On this form, which is made in masonry, so in bricks and plaster, they prepare a prototype, one of the 13 prototypes. This prototype is called grandmother. This is the jargon of the construction site, the grandmother.
So the workers use the term grandmother?
Yeah.
Nonna?
Nonna in Italian.
No,
this is a matriarchal line.
I see, okay.
Oh, the grandmother, so we have 13 grandmother. It's used like a sand mold to prepare 2 or 3 mothers, mamme. The mamme are identical to the masonry piece. So to the
To the
piece,
masonry.
Yeah.
So the masonry was used to form the grandmother.
Yes, and the grandmother was used to form
the mother.
The mother. 2 or 3 mothers. So more teams of workers can work on the mother and produce 108 daughters.
I see.
The daughters are identical to grandmother.
Okay.
Yes, perfect, identical. So they prepare 107 daughters because Nervi used also the grandmother. They are identical, so you can do this. And you, in the origin, you could check the grandmother in the dome, the 13th grandmother in the dome.
So let me just make sure I understand this. Okay, so you have the masonry form that forms the grandmother, and the grandmothers are used to form the mothers, which are then used to form the daughters. And the daughters and the grandmothers are exactly the same.
Exactly.
Except for the daughters, you mentioned earlier to me off camera, that have protruding steel
Yes,
to join.
sure.
So the dome behind us is mostly, for the large part, made of daughters,
Absolutely.
except for 13 grandmothers.
Yeah.
I wonder why he used 13 grandmothers. Did he just for fun, or did
No,
he run out of
for economy.
for economy?
Yes.
Oh, he
Otherwise,
ended up
you have to
using-
waste the grandmothers.
I
Now, in this way,
see.
you can use it.
Oh, interesting.
But the grandmother was darker because you
It
have
was
to
reused.
put oil inside to make this use of like a sand mold.
So it wouldn't stick to
Yeah.
the mold.
Yeah.
So-
So it was darker, and so you can check.
I
Maybe it
see.
was also to make understand us something of the construction process, maybe.
I see.
And at the end, they put these thousands of pieces on the top of an Innocenti scaffolding. Nervi rented the scaffold only for 2 months. And on the top of the scaffold, he reproduced the dome like a 3D puzzle, a huge 3D puzzle. And because the pieces are very light, so you can move easily, they were stacked in a very perfect way, very ordinate way. And at the end, on the channel that the rhomboidal elements formed, you put the rebars and you cast the concrete.
So very similar to the half dome in Turin.
Yeah,
Right? So
absolutely.
you put these together, it forms a natural channel.
Yeah, absolutely.
Steel reinforcing.
Yeah.
Pour the concrete, and it becomes one unified
Yeah.
dome. And if you look at it, you don't see, and you imagine that it was poured all at once.
The photographs by the construction,
Yeah.
they are so clear of
Yeah.
this process, but otherwise you can't imagine that this was a 3D puzzle.
Because if you look at it in detail, it's so perfectly made. The geometry is so perfect,
Yeah.
and I imagine there must have been some precision at the construction site to build this in a way that's so precise that it came together
Yeah.
so well.
It wasn't handmade work, so it's a sort of sculpture because each single pieces are made by the workers by hand using trowels, so in a very perfect way because they are made by the man. So it's a very accurate work by hand, and this was a perfect kind of work for Italy in that moment, because Italy in that moment have a lot of manpower who have to be made at work, and they are not very skilled professionists, so they can't maybe produce something in steel, but working with hands, with plaster, with concrete is a very easy things to do, and they can be very, very good. The main difference between this kind of dome and one of Candela or Torroja, they are smooth. This is possible only because of the Nervi system, because otherwise
Right.
it can be built. It's not. It's too much costly.
Correct. So later in the lecture, we're going to talk about Candela and Torroja that we just mentioned, and these are Spanish engineers where their domes are smooth on the underside. And what's special about Nervi, as we've been mentioning, are these ribs, this ribbed pattern that we see throughout of Nervi's work, and again, possible because of this construction system. And in this system here, in this dome, these inclined buttresses at the outside that you see from the outside of the building, they collect 4 ribs from the inside. So 4 ribs from the inside come together, and they're collected by these inclined buttresses, which then would have a horizontal thrust on the outside. So in order for this dome not to flatten and collapse, there has to be something holding in this horizontal force of this dome, and that's going to be underground. There's a ring that holds this dome together and essentially resolves these horizontal forces of the inclined buttresses. So very special structure. I like it very much. It's a beautiful design, and certainly one of his masterpieces. I think maybe even this one is the one he's most famous for. I'm not sure, but
and this is the best version of the Nervi system. The more simple, because the building is structure. There is nothing. There is no other things.
There's no decoration.
There is nothing.
It's pure structure.
Pure structure.
Right.
And this is one of the language of the Italian school of engineering, which is formed in that period and which was one of the most important of the war.
When I first introduced you, I mentioned that you co-curated an exhibition on Nervi, and as part of the exhibition, there was this beautiful model on the Sports Palace. Can you describe that model? And we have some images to show our audience as well.
The model was huge because it was not the model of the building, but of the construction of the building. And it was 4 meter diameter, and it was produced to make clear this process of grandmother, mother, and daughter to everyone, because the exhibition was open to everyone, not only to architects or to engineers. And it was so interesting because during the production of the models, we understood a lot of things, of the construction, of the problem of the construction. It was a very useful model because we could understand all the process, because we want to reproduce all the process Nervi used.
So in making the model, you used the same procedure, the same process that Nervi used, which I'm sure made you appreciate much more what Nervi did here, right? Making it at such a small model with such a complicated process, but I can imagine making it at this scale.
Yeah.
The challenge that Nervi had.
We made a lot of errors, maybe Nervi not. For us, it was a very strong work, and we have to correct a lot of things. But here, we think that there was not correction.
At the same time that the Palazzetto was being built, so was another large dome, as well as a covered stadium for the Olympics. For the stadium, Nervi could have repeated the same design as that which he used in the Florence Municipal Stadium, but instead he finds a new form using the Nervi system. So we're going to look at this next. But first, before we move on, I want to thank you, Tulia, so much for being part of this conversation and teaching us so much about Nervi. It's just been wonderful having you here. Thank you.
It was a pleasure for me. Thanks to you.